All right, let's have a look at these ones. I don't know why, but let's have a look at 9. Let's go backwards. All right, so use the derivative of tan cubed. I'm going to make it y because I think this might help you understand it better. So it would help if I could write. All right, so if I find the derivative of tan cubed, remember tan cubed x is the same as tan x all cubed. So the 3 can come to the front. I'm doing tan x to the power of 2, and then I've got to go inside, so it's a chain rule, and tan x goes to sec squared x. So you can see here that I get 3 tan squared x times, now it's sec squared x, but if I look at the actual question I'm going to have to answer, it's got tan to the power of 4. How am I going to get some more tans to times it by? I'm going to change sec squared. We know sec squared is 1 plus tan squared x. So that way I'm going to write the fourth term first. So I'm going to get tan squared times tan squared, so I'm going to get tan to the power of 4. And then the other term I'm going to get is 3 lots of tan squared x's. All right, so that's looking at dy dx. So if you think about if dy dx equals that, if I do the opposite, so if I integrate both sides, so if I integrate this left-hand side, so this is d by dx of y, so if I integrate, I just get y. So y being tan cubed x. So thank you, Hannah, tan cubed x equals, so I'm integrating, they've both got 3 in them, so I'll put a 3 outside. I'm integrating tan to the power 4x dx, and I'm integrating tan squared x dx. And the one they actually have asked in the question to find is this one, just this bit here between 0 and pi on 4. So if I rearrange it, and so what I might do is put 1/3 here. So divide both sides by 3, so that makes it a bit nicer. Now, so then I just want this on one side by itself, and I want it between 0 and pi on 4. So let's pretend that's by itself, and I'm putting everything else on the left. So on the left, I've already got a 1/3 tan cubed x. So I've already got that. And I've also now going to have, I'll just put that, so, but I want it between 0 and pi on 4 now. I'm also going to have now minus, and this will be tan squared, so this term here. Now, it's very hard to integrate tan squared, but of course I do know tan squared is the same as sec squared x minus 1, just kind of going back again to the sec squared, because sec squared is easier to integrate. Okay, so we know that if I put pi on 4 in, I know tan pi on 4 is 1, so 1 cubed is pretty easy, that's just 1. So I've got a 1/3 for that one when I sub in pi on 4. When I sub in 0, tan 0 is 0, so I've got a 1/3 minus 0. Yes, all right, so that's for kind of that section there. Minus, all right, now sec squared we know goes to tan x, and minus 1 will go to minus x. I'm going between 0 and pi on 4, and since I'm about to run out of room, let's have a look at this. So tan pi on 4, I'm doing a different colour so you can see. Actually, I'll just do it normally. So we've got tan pi on 4, which we know is 1, minus, I keep forgetting to change that. So that's a, what was I doing? Minus. All right. So we've got subtract tan pi on 4, which is 1, take away pi on 4. So that's putting all the pi on 4 in, and then we're minusing, putting all the zeros in. But 0 is fine because tan 0 is 0, minus 0, that's 0. So we're kind of subtracting 0 here. Now, if I and put all that, oh yes, I can do that. All right, so if I put all that together, what have I got? I've got a third minus 1, so that's negative 2/3, and I've got this positive pi on 4, so I'm going to say pi on 4 minus 2/3. Let me write that again, pi on 4 minus 2/3. There we go. So that is for number 9. So let's go back up and look at number 8. Okay, so for number 8, similar thing. So we're also having a look at the derivative and then rearranging to find a different integral. So it says use the derivative, maybe if I put it on this side it will help, of x inverse sine x. So let's have a look at y dx. When we do that, differentiate the first, you get 1 times the second, so this is a product rule. Differentiate the second, so, and then we're timesing by x. So from your reference booklet, you can see that if we differentiated inverse sine x, we would get 1 on square root of 1 minus x squared, and then we're timesing by the x. So I'll put the x on top, so this is what you get. Now, if you do the opposite, so that's a differentiation. So now if basically what I'm doing each time is I'm integrating everything with respect to x. So this will become y on the left-hand side, which is x inverse sine x. This is now the integral of inverse sine x dx with respect to x, and the integral of x on square root 1 minus x squared dx. All right, so what do we actually want? We want the integral of inverse sine x between 0 and a half. All right, that's okay. So let me do it over here. 0 and a half inverse sine x dx equals. All right, so that's that bit there that we want. So that is equal to x inverse sine x, and that's between 0 and a half now, and then minus, I'm putting this term across here, so minus the integral of x on square root 1 minus x squared dx. Now, so this part's easy to do. So we've got a half when we sub it in, inverse sine of a half, so we can do that. We get 30 degrees, so that's pi on 6. So I'll just times by pi on 6 there. Inverse sine of 0 is 0, so we're going to end up minusing 0 here. All right, so just to get it ready, I know I've got pi on 12, which is good because there's that bit there in the answer, so we know we're on the right track. All right, this bit here, in order to differentiate, you can see that it's not too bad, except this x squared here and with the x on top is the one that's kind of going to give us grief. So if I make u equal to x squared, you can see that du would be 2x dx. So what I could do is change this to a 2 and this to a half. And then I've got this 2x dx that just gives me a du, and that makes the bottom easier. So now I have minus a half. If I did it in terms of u's, that would be 1 on square root 1 minus u, yeah, just u, right, because I made it x squared, du. All right, so that doesn't link to any of the ones in the reference booklet really, but it is just 1 minus u to the negative a half, really. Let me see, I'll write it here so you can see it clearly. So really, I've just got 1 minus u to the negative a half with respect to u there. Now, when I do that, I feel like I've made an error somewhere, so bear with me. All right. So I feel like I need a negative, so that should be a positive. Let's just check. So if I add 1 to that, I get 1 minus u. If I add 1, I get a half, and I'm dividing by a half. So if I'm dividing by a half, it's going to cancel that half that's out the front. Not only am I dividing, right, so this is, yeah, I'm dividing by a half, and there's because of this negative in front of the u, so I either have to put a negative here and change that negative, that there, or I could divide by negative a half instead of the half. So if I did change that like that, so sorry, this is not the greatest explanation. All right, and I've lost everything. So that was a half divided by a half. So those halves cancel. Oh no, I don't need the du because I've already integrated. All right, let's just do that again. All right. So as I said, there's different ways to do it, but so I made sure that the derivative of the inside was on the outside, so then I don't need to worry about it. So then what I would do is 1 minus u, I would add to the power, so I get a half, and divide by that power. There it goes. So they actually cancel. Now, remember that was in terms of u's, but I actually want it in terms of x's. So I'll just quickly change that to x's. So actually I've got 1 minus, what was my u? My u was x squared. 1 minus x squared to the power of a half. All right, that's going to annoy everyone. So 1 minus u, which is x squared, to the power of a half. And we're doing that between 0 and a half. Sorry about that. Okay, so let's try. Let's put a half in, so we get 1 minus a quarter, which is 3/4, and we've got the square root of that. So square root of 3/4 is square root 3 on 2. And then we've also put the 0 in, and we get 1 to the power of a half, which is just 1. So I'm subtracting 1. So hopefully that is the answer. Yes, thank goodness.